Right now, the most advanced AI agents in the world are forced to read the internet using, well, basically bloated software that was designed for human eyeballs over a decade ago.
Yeah, it's wild when you actually think about it.
It really is. I mean, it is like finding a coal-powered steam engine hidden inside this sleek, futuristic spaceship.
Mm.
We are living in this age of massive automation.
Well, absolutely. AI that can research complex topics or,
Mhm.
book flights or analyze thousands of financial reports in a matter of seconds.
Exactly. But if you look under the hood at how these brilliant systems actually extract their information from the web, the underlying machinery is completely stuck in the past.
It's one of the great hidden bottlenecks of modern tech.
Yeah.
I mean, we have completely revolutionized what we do with data.
Right?
But until very recently, we really haven't fundamentally changed how we gather that data. We've
Yeah.
been forcing these hyper-fast machines to navigate the web using tools designed entirely for you, the human user,
Yeah.
with, all the graphical baggage that comes with it.
Which brings us to our mission for this deep dive. Today, we're exploring a project called Lightpanda.
Yes.
We've got their official GitHub repository documentation in front of us. And basically, it is an open source headless browser designed from the ground up specifically for AI and automation.
They're built entirely for machines.
Right. We are going to look at why developers are essentially burning down the legacy ways of web scraping, how they are building these lightning-fast, purpose-built replacements, and what this architectural shift actually means for the future of AI data gathering.
It's a huge shift.
It is. And to really grasp why Lightpanda even needs to exist in the first place, we have to look at why the old ways of pulling data from the internet are just entirely broken today.
Yeah, if you've ever, tried to write a simple script to grab data off a modern website, you know exactly how frustrating this transition has been.
Oh, for sure.
In the early days of the internet, scraping a web page was trivial.
Mm.
It was as easy as sending a simple HTTP request using a basic command line tool.
Something like CURL, right?
Yeah, exactly. Like CURL. You would ask a server for a web page, and the server would just hand you back a neat static text file full of HTML.
Just boom, there it is.
Right. All the data was right there, just sitting in the code, waiting to be read.
The server did all the heavy lifting of assembling the page,
Yeah.
and your script just had to, well, download the finished product.
It's just simple and efficient.
But the web doesn't work like that anymore. Today, JavaScript is absolutely everywhere. Modern websites are built as single-page applications or SPAs.
Which changed everything.
Right. And for anyone who isn't a web developer, an SPA is a website that loads a single basic HTML skeleton just once.
It's an empty frame, basically.
Yeah, exactly. And then it dynamically updates the screen as you interact with it, relying entirely on these super heavy JavaScript frameworks like React, Vue, or Angular to actually function.
And they also rely really heavily on AJAX, which is a technique where the website quietly talks to the server in the background.
Without you knowing.
Right, pulling in new data without ever forcing you to reload the page. Add in infinite scrolling features, and the web has just become highly dynamic.
Constant movement.
So if your basic automation script sends that same simple HTTP request to a modern website today, it doesn't get a neat package of data. It gets a practically blank page.
Just nothing.
Right. It downloads a massive skeletal file that essentially says, please hold while I download and execute 5 megabytes of JavaScript to actually build the data you're looking for.
And a simple HTTP request tool doesn't know how to run JavaScript.
Not at all. It just stares at that blank page, totally stuck.
So to get around this, the current industry solution is, well, it's basically brute force.
Pretty much, yeah.
If you need JavaScript to run so your AI can actually see the data, you are forced to use a real full-weight web browser.
Which is painful.
Yeah. Developers end up running hundreds or even thousands of instances of desktop Chrome on their servers in what's called headless mode.
And headless just means the browser's running without actually drawing the graphical window on a physical monitor.
But under the hood,
Under the hood, it is still the full, heavy Chrome application.
I mean, using a full desktop browser like Chrome on a server just to scrape some text for an AI it's like hiring a full 80-piece symphony orchestra just to play a single piano chord.
That is a brilliant analogy.
It is wildly bloated and incredibly expensive to run.
That symphony analogy really perfectly captures the scale of the waste. Desktop browsers like Chrome or Firefox, they are heavily optimized, but they are optimized for humans.
Right, for us.
Yeah, they are engineered to manage your bookmarks, run browser extensions, render smooth 60 frames per second animations.
Handle complex user interfaces, juggle dozens of tabs without crashing your laptop.
Exactly. All of those features require a massive amount of RAM and CPU power.
And when you are an AI agent or just a developer running a massive scraping operation, you don't care about smooth animations.
Not at all.
But you are still paying the compute cost for them. When you need to read thousands of pages a second, spinning up thousands of symphony orchestras every single minute becomes a massive, highly expensive bottleneck.
Which is totally unsustainable.
Right. So if throwing more massive servers at Headless Chrome is a losing financial battle, you can't just, fire the violinists and tweak the orchestra.
No, you have to burn it down and start from a completely blank page.
Which brings us to Lightpanda. It isn't just another iteration or a stripped-down version of Chromium or Blink or WebKit.
Which are the underlying rendering engines for Chrome and Safari for context.
Lightpanda is built entirely from scratch.
And deciding to just start over is almost unheard of in modern web development, because browsers are arguably some of the most complex pieces of software humanity has ever written.
They took on that monumental task using a modern, low-level system programming language called Zig.
Yep.
Specifically, the project heavily relies on Zig version 0.15.2, which makes up almost 3/4 of their entire code base.
Zig is fascinating because it's designed to compete in the same space as legacy languages like C or C++A.
And the heavy hitters.
Right, but it gives developers incredibly precise, manual control over memory allocation and hardware. Older code bases often suffer from hidden memory bloat because of how they handle background tasks and garbage collection.
Just leaving messy code lying around.
Basically, yeah. By building the browser in Zig, they aren't just making it a little faster, they are rethinking resource management at a surgical level. They dictate exactly how every single byte of memory is used.
And the performance statistics from this architectural rebuild are just wild.
Unbelievable, really.
In benchmark tests requesting 100 pages from a local server, Lightpanda demonstrated a 9 times smaller memory footprint than Chrome.
9 times.
Yeah, it executes 11 times faster, and it has an instant startup time.
A 9x reduction in memory means you can run 9 times as many browser instances on the exact same server hardware.
Which is huge.
That fundamentally changes the economics of web automation.
Okay, let's unpack this, though. Because as impressive as those numbers are, there is a core design philosophy driving Lightpanda that initially tripped me up.
What was that?
The project is described in the repo as being highly opinionated, specifically because it operates entirely without graphical rendering.
Right.
So if it doesn't draw graphics on a screen, how can it even call itself a browser? I mean, isn't looking at things the whole point?
To you and me, yes.
Yeah.
But we are building tools for machines now. What's fascinating here is understanding what a browser actually is beneath the paint job.
Okay.
A browser's core job isn't actually to paint pixels. Its core job is to construct a structured map of data. When Lightpanda visits a page, it uses a network tool called libcurl to handle the HTTP requests.
Okay, got it.
Then it uses an HTML parser. They use one called HTML5ever to read the raw code. From that, it builds the DOM tree.
The document object model.
Yes. It's a hierarchical branching map of every single element on the page.
Yeah.
Every paragraph, every link, every hidden data attribute is mapped out in relation to each other.
Like a blueprint. It's
Yeah.
exactly like a blueprint. To an AI, the graphical rendering, the colors, the pixel-perfect alignment, the drop shadows, none of that matters.
It just doesn't care.
The machine just wants to navigate that DOM tree to find the raw text or the specific link it needs. Lightpanda processes the network requests, parses the HTML, and builds the DOM exactly like a normal browser.
It just skips the final step.
Right, it skips the final, incredibly resource-heavy step of calculating how to paint that picture for a human eye that isn't even looking.
I think I get it. It's like a master chef reading a complex recipe.
Oh, I like that.
They gather the ingredients, they cook the meal, they understand the exact nutritional data of the food perfectly, but they skip the final, time-consuming step of actually plating the food to make it look pretty for a customer in the dining room.
Because there is no customer.
Right, and AI just needs the nutritional facts. It doesn't care about the presentation.
That is spot on. The plating is what costs all the money in server compute.
But that brings up the elephant in the room we talked about in the beginning. JavaScript.
Ah, yeah. If Lightpanda strips away the paint job, I'm assuming it still has to somehow execute those massive React or Vue scripts in the background. Otherwise, that DOM tree we just talked about would just be completely empty.
It absolutely has to run those scripts.
Yeah.
Lightpanda can't just parse static HTML.
Mm.
It has to have a brain capable of executing complex JavaScript at scale, so those modern single-page applications actually populate with data.
So how do they do that if they built it from scratch?
Well, to do this, they didn't reinvent the wheel. They integrated the famous V8 engine.
Which is the exact same open-source JavaScript engine that powers Google Chrome and Node.js?
Exactly. They integrated it via a custom bridge project called Zig.js Runtime. And this is a highly technical achievement.
Why is it so hard?
Well, V8 is a massive, incredibly complex C++ code base. The Zig.js Runtime acts as an ultra-fast translator, allowing Lightpanda's lightweight Zig environment to efficiently hand off the heavy lifting of JavaScript execution to the V8 engine.
And then seamlessly take the results back.
Precisely.
So this allows Lightpanda to support the features that modern websites rely on.
Right.
It handles AJAX and the XHR API. It supports the Fetch API, which is just the modern way a web page quietly asks a server for new data in the background.
Crucial for SPAs.
Yeah. It manages cookies, allows for custom HTTP headers, proxy support, and it can even obey robots.txt rules if you configure it to.
But this raises an important question about the sheer scale of what they're attempting, though. Integrating V8 gives you the engine to run JavaScript, but it doesn't give you the car.
What do you mean by that?
JavaScript interacts with a browser through web APIs. A web API is basically a standardized bridge, everything from a script asking to manipulate the DOM, to accessing local storage, to playing audio.
Okay.
There are hundreds of these standard web APIs. When you build a browser from a blank page, you don't get them for free. You have to manually map and build the underlying logic for every single one of them.
Oh, wow.
It's like trying to rewrite the entire standard library of the internet.
Which naturally leads me to think about the developers who are actually going to use this. I mean, imagine trying to convince an engineering team to adopt this.
Good luck.
Right. They already have millions of lines of automation scripts perfectly written, tested, and deployed for Chrome. Developers are notoriously practical.
They don't want to break things.
They won't adopt Lightpanda, no matter if it is 11 times faster, if it means they have to rewrite their entire code base to accommodate a browser that is still actively mapping those hundreds of web APIs.
Yeah, if you force a massive rewrite, your new tool is dead on arrival. Yeah. It has to play nice with the existing ecosystem. The creators of Lightpanda solved this by building in a universal translator.
A translator?
Yeah, Lightpanda exposes a CDP server on port 9222.
CDP. The Chrome DevTools protocol.
It's the standard communication protocol that almost all modern automation tools use to talk to Chrome. By speaking this exact same language, Lightpanda makes itself a drop-in replacement.
Oh, that's clever.
Extremely clever. It is compatible right out of the box with heavily used industry tools like Puppeteer, chromedp, and Playwright. You don't rewrite your scripts.
You just point your existing script to Lightpanda's port instead of Chrome's.
And your script genuinely thinks it's talking to Chrome.
Here's where it gets really interesting, though. Because Lightpanda is actively being built and is still a work in progress, this clever integration leads to some incredibly weird technical quirks.
Oh, definitely.
Specifically, there's a phenomenon I'm calling the Playwright paradox.
It is a perfect case study in how modern software architecture can trip over its own cleverness.
Okay, lay it out for us.
So Playwright is a wildly popular automation library, but it doesn't just blindly send your commands to the browser. It uses an intermediate JavaScript layer that acts a bit like a smart manager.
A manager.
Right. Before it executes a command, this manager checks to see exactly what features and web APIs the browser actually supports, and then it dynamically chooses a specific execution strategy based on that profile.
Wait, let me make sure I have this straight. Because Lightpanda is actively under construction, they are constantly rolling out updates that add new web APIs.
Right.
You would think adding a brand new, fully functioning feature only makes things better. But the project explicitly warns that if a script works perfectly today, it might actually break and crash in a future version of Lightpanda. That feels totally backward.
It happens precisely because of that smart manager layer in Playwright.
Is it sort of like, let me try an analogy. Is it like upgrading your car's engine with a massive new turbocharger?
Okay, I'm tracking.
You expect to go faster, but instead, the car's internal computer gets confused by the new power curve, panics because it doesn't know how to mix the fuel for it, and just refuses to start the car at all.
That's a great way to visualize it. With Playwright, if Lightpanda pushes an update that adds a brand new web API, Playwright's manager sees it and says, oh, excellent, you support Feature X now. I'm going to switch to my highly optimized execution strategy for Feature X. But that new complex strategy might also rely on Feature Y and Feature Z, which Lightpanda hasn't finished building yet.
Oh, yeah.
So a script that worked perfectly yesterday suddenly crashes today, all because Lightpanda got slightly more advanced and triggered a different logic path in Playwright.
It's a fascinating look at the unintended consequences of abstraction layers. We build these intermediate layers to make development easier, right? To hide the complexity from the user.
But it backfires.
Yeah, when you introduce a completely foundational new tool like Lightpanda that is essentially mimicking an established giant while still under construction, those helpful abstractions can suddenly work against you.
Totally.
The developers actually ask that if you encounter an issue, you open a GitHub ticket and include the last known working version of your script.
Because they can't possibly predict every single intermediate code path Playwright might decide to take.
It really emphasizes that despite the incredible speed advantages and the fact that this project has garnered massive attention in the open source community, we need a reality check on where it stands today.
Yes, absolutely. It is currently in beta. You will encounter errors or crashes if you deploy it in complex environments.
But they are taking a very rigorous approach to stabilizing it. Lightpanda is actively tested against the standardized web platform tests, or WPT.
Which is a huge deal.
Right, this isn't some internal padded metric. The WPT is the exact same massive cross-browser test suite used by Chrome, Firefox, and Safari to ensure they are interpreting the web correctly.
They are measuring themselves against the true, unforgiving standard of the web.
And while they're doing that, they are making it highly accessible to developers. You don't have to be a Zig master to compile it yourself.
No, not at all. They offer pre-built deployment packages and nightly builds for major operating systems, making it very easy to spin up in a test environment. You can use Docker images for both AMD 64 and ARM 64 architectures.
Or WSL2 on Windows, Mac OS, Linux, it's all there.
Extremely accessible.
While reading through those setup and deployment instructions, though, I hit a detail that I really want to push back on.
Okay, let's hear it.
The documentation clearly states, by default, Lightpanda collects and sends usage telemetry. Now, you can disable it by setting a specific environment variable, but it is turned on by default. Wait, this is an open source tool, explicitly designed to bypass the bloated, tracking-heavy browsers built by big tech.
I see where you're going.
And yet, they have tracking telemetry turned on by default. Why would they do that? It feels entirely contradictory to the privacy-first ethos you usually see in these kinds of low-level projects.
If we connect this to the bigger picture of how an open source project actually survives, it makes total sense. Look at the sheer mountain of work they're trying to climb.
It's a lot of work.
They are trying to map hundreds of complex web APIs, and they're doing it with a core team of roughly 24 contributors.
That is a tiny team to be building a web browser from scratch.
It is microscopically small. For a beta project with highly limited human resources, anonymized usage data isn't about tracking users to sell ads. It is pure operational triage. If you have 24 people, you cannot build everything at once. You have to know what is actually breaking in the real world to know what to prioritize.
So it's diagnostic.
Exactly. If the telemetry shows that 90% of automated scripts in the wild are crashing because they are trying to call one specific obscure method within the fetch API, the team instantly knows they need to build that exact method next week.
Wow, okay.
Without that default telemetry, they are flying blind, relying on people to manually report bugs. Having it on by default ensures they get the critical mass of diagnostic data they need to actually finish building the browser.
Okay, when you frame it as triage, that actually makes sense. It's less about surveillance and more about survival. They need a heat map of where the ecosystem is actually breaking.
The fact that the project uses a very strong copyleft open source license, the AGPL 3.0, really reinforces that this data collection is about community development, not proprietary lock-in.
So what does this all mean? We've covered a lot of ground today, from the death of the simple CURL requests to the inner workings of Zig memory management and the V8 engine bridge.
There's a lot to process.
Let's synthesize this. For you listening, whether you are an engineer writing scraping scripts, an AI researcher, or just someone fascinated by where the architecture of the internet is heading, Lightpanda represents a major paradigm shift.
A huge one.
For years, the massive computing costs of running thousands of heavy graphical Chrome instances have been a hidden tax on AI development.
A very expensive tax.
By stripping out the graphical bloat, rethinking memory allocation from the ground up in a low-level language, and playing nice with existing tools through protocols like CDP, Lightpanda proves that this massive tax isn't mandatory.
It means the computing costs of gathering training data for large language models or running autonomous AI agents could absolutely plummet.
And when compute costs plummet, AI development becomes far more accessible to everyone, not just the megacorporations with unlimited server budgets.
It fundamentally democratizes the ability to operate on the web at scale. But it also leaves us with a fascinating and slightly provocative final thought.
Oh, what's that?
For the last decade, websites have relied on the sheer heavy footprint of desktop browsers as a sort of informal proof of humanity.
Like a bouncer checking your ID.
Right. If a visitor requires a massive amount of RAM and meticulously renders all the CSS styling perfectly, security systems assume it's probably a real person, or at least a very expensive bot that most people can't afford to run.
Right, because why would a bot bother rendering the CSS?
Exactly. But if headless browsers like Lightpanda become incredibly lightweight, executing flawless JavaScript while remaining virtually invisible, and running 100,000 instances suddenly costs practically nothing, how will websites adapt?
That is a scary thought for web administrators.
This raises an important question. Are we about to see a new arms race where websites have to develop entirely new invisible CAPTCHAs, deep behavioral analytics, or cryptographic challenges just to differentiate between a human's bloated browser and an AI's hyper-optimized Lightpanda?
If you build the perfect hyper-efficient piano, someone is inevitably going to build a security system that only lets full symphony orchestras into the concert hall.
Exactly.
It is a fascinating architectural arms race to watch unfold. Thank you for joining us on this deep dive into the hidden machinery of the automated web. We will catch you next time.